Hey guys, so in this video we're going to be talking about what happens when there is a fault in a control line for a single cycle implementation. There we're going to go ahead and consider this example right here. So over here it says that ALU SRC has a fault. ALU SRC has a fault where shown by X, which is right here is shown by X, and the fault is the control line is always stuck at 1. So ALU SRC would be 1 no matter what instruction it is, what control unit it is, or what opcode it is. This would be 1. It's stuck at 1. Okay, so this is the problem. And we have some instruction below right here, and we're going to see which instruction gets affected by this fault. By affected, we mean which instruction is not going to work properly. So this affected word means which instruction is not going to be working properly. And I'm going to go ahead and circle whatever is affected. Okay, and I'm not gonna do anything to the one that is not affected. So let's go ahead and go through these instructions. So first up is add. So we know that add is a R type instruction. Let's go ahead and go to our green sheet and see what add does. So add right here. So the job for add is we're gonna add RS with RT, and we're gonna go ahead and store this value to RD. So we know that this is RS, this is RT, and for this instruction, we want these two get added, RS to be added with RT in ALU. However, and as you can see over here that RT is 0. And this one is some value that is coming out of, this is going to be some immediate value that would be initially given to the register file by this instruction. However, add does not have that value. Add does not have a immediate value with it. It has RS, RT, and it has RD, which is going to be right. RD is going to be right here. So we don't know what this immediate value is, and we want 0 for this instruction because we want RS and RT to be added. However, we know that ALU SRC is 1, therefore this is never going to be 0. This is not going to work. This is going to be 1, and it's going to want that immediate value that we don't have for this instruction. Therefore, add is not going to work. Add is a affected instruction for this fault, so add doesn't work properly. Next up, let's go ahead and look at sub. Sub is a very similar instruction to add. The only thing different is the sign. So let's go ahead and scroll down and find sub. Sub is right here. So as you can see, it is very similar to add, where we're getting RD is equal to RS minus RT. So this minus sign, so what is the difference between add and subtract? The only difference is everything stays the same except for ALU. Over here, we want to subtract. So RS still, this should still be RS, this should still be RT. Matter of fact, this should be RT too. So ALU takes in RS and RT value, and we still want 0 right here. We don't want 1 because same thing as similar before. Our sub does not have an immediate value, so this 1 we don't know what it is. So since ALU SRC is giving out 1 to the mux, we're not going to get 0, we're going to get 1. So we are going to want the immediate value, but we don't want that. We want to subtract RT from RS. Therefore sub is also going to be an affected instruction for this fault. Let's go and clear this up a little bit. There's so much going on because load word, store word is going to be slightly different. And I'm going to do load word and store word together because they're very similar to each other. Okay. All right. So let's go ahead and talk about load word and store word. So what does load word and store word do? Let's go ahead and pull up our green sheet and see what's up. So right over here we have load word where RT is equal to a value. This is the memory address where RS plus sign extender immediate, and then we're going to get the memory value, and we're going to get a value from the memory depending on the address and save it in RT. So load word is store word is slightly similar, is just the other way around, and you can see it right here. It is very similar, it's just the other way around. So this is going to be RT. Over here is going to be RT, and we want RT to be register destination for load word. So but over here, because we have that immediate value for load word, we want the sign extended version of that. So we want the second value of the ALE to be an immediate value, and this is going to be RS. So RS is going to get added to the immediate value, and then that's going to be our memory address, and we're going to get the memory data. We're going to get the memory from we're going to get the memory from that address, and we're going to go ahead and add it to the RT value. For that, we want one. We actually want one. We don't want RT because RT is going to be destination register in this case, and we're going to be adding RS to the 16-bit immediate value. So we actually want one, and we know ALU SRC is one, therefore store word and load word, which is very similar to each other, both of them want one. And you can also go to this table right here, which is also on your book, and you can see that ALU SRC, you want load word to be one, you want store word to be one. It's right there, store word to be one. And as you can see also right here, the R type instruction, you want ALU SRC to be 0, which is very similar to add and sub. We know add and sub is a R-type instruction. So how about so that's taking care of LW and load word and store word, which is not a problem when ALSRC is stuck at one. How about BEQ and BNE? They are very similar instruction as well. But for this one, what we want is we want to compare RS with RT, and you can find that right over here. Let's go ahead and scroll up to get a better view of what BEQ actually does right here. BEQ is comparing RS to RT, and is going to go ahead and go to the branch address plus PC plus 4 if RS is indeed equal to RT. So what is going on is it does have a branch at immediate value, but that is our branch address. That is not something we want to compare it with. We want to compare with RT, and we want to compare with RS. So ALU wants the RT and RS value. So like I said before, this one actually wants 0 because we want to compare RT with RS, not the branch address. So if this is not 0, this is 1 instead of 0 because it is stuck at 1, we are going to be comparing it with the branch address rather than the RT. So this might be this 0 component right here for ALU might be 1, might be 0, you never know. And it might not be what you want. It might not be the value when you want to jump. So BEQ is definitely at fault, and BNE, which is very similar, is also at fault because BNE is just like the opposite of BNE, so BEQ. So over here, for BNE, we're just comparing if it's not equal to, or where BEQ, we're comparing if it's equal to. So BNE is also at fault. How about ADDI and ORI? We know ADDI and ORI are immediate instruction. And very small difference between ADDI and ORI and add and sub is basically ADDI is actually getting an immediate value. We're actually going to be getting an immediate value and sign extended by 30 sign extended 32-bit, and we're going to be adding RS to that immediate value. We want to add that immediate value to our RS. I'm sorry, this should be RS right here. So we actually want 1 over here. We don't want 0. We want 1. So this is, since ALUSRC is stuck at 1, this is perfect. We want 1. We got 1. We're going to be adding 1 to RS. So ADI is going to be good. It's not going to be at fault. It's not going to be affected. ORI is very similar. ORI also gets the immediate value, and then we're going to be ORing it with RS. And an example of that is you can find in your MIPS green sheet. There we go. There's ORI. We're going to be putting RS, and then 0 extended immediate value right here. So you might say that there might be like a little problem because this is sign extended, but that's not what we're asking right here. We're asking what would happen if ALU SRC is 1. So since we do for ORI, we do want this 1 right here, and then ORing it with RS, this should be fine. This ORI should be good. So add is good, ORI is good, load word, store word is good. However, add, sub, BQ, and BNE is affected by this fault for stuck at 1. That's it for today. Thank you.